All right, so from Google Classroom, I'm just repeating this for the video, the absent students. There's a link in today's post. It will take you to the state practice testing site. So this is something that you can do on any Chromebook, any computer. It's not something that you have to do from the secure site or anything. And again, all my first period students, you guys are gonna need to go to Ms. Durkee's room tomorrow for first period because I have freshman testing in here. So if you're watching this at home for Tuesday, you will not come to my class for science. You will go to Ms. Durkee's room. So is everybody logged in? Are we in Google Classroom? Are you on this site?
Yeah.
Okay. Slow me down if I go too fast. Go to the practice tests. Then just hit sign in. Because we're doing guest. Obviously select grade 8. Do you not have your Chromebook still? You do not have it? Okay. Have they told you when you're going to get one? Do they know that you still don't have one? Okay. I'll try calling down to the office and see. Obviously, we're going to go to the to science material. There's a 22, there is a 21, and there is a 19. We're going to go to the 22 today.
Okay. Wait, so it says.
Yes. Yep.
Okay.
Hold on. So it says, go back to grade 8. It says start G8 science SPR for spring 22 released items.
Okay.
So I always just look for science and, because we're in grade 8, so science and 22, right? Or if I tell you to go to science and 21, I think tomorrow what I'm going to have you do is go through the 19. So you'll follow these steps and you'll go to the 19. All right, so we go to this and then just hit, all of these are selected on. Obviously, you know, you can adjust those, but we'll just hit select. The skip text to speech. Does anybody use the text to speech option?
No.
Okay. If you want to use it, you need to make sure that you practice with it and give that a try. If you're not, just hit skip TTS, which is text to speech, and hit begin now. Okay. And so obviously to navigate from question to question is right here. You have like the note option, and you guys should, I mean, you're probably familiar with those, right? This is not graded, this is just to write down. Obviously you'll also have a piece of paper. Anytime like there's Punnett Square stuff, I would recommend that you use the paper. If you need a note and you want to use that note feature, that's fine. The zoom in and zoom out, you know, that's not usually super helpful. I mean, if you want to, you know, it zooms it in, zooms it out. Okay, so what we're gonna do, I would like you guys to just make sure that you stay with me. Do not like work ahead, don't rush through. I wanna go through these because sometimes there are just things that they try to trick you. They try to intentionally make it so that they are testing how well you're interpreting something, maybe not testing your knowledge. They try to get you off track. So I'm gonna try to show you some of those pitfalls or some of those things that hopefully you can help avoid, okay? So make sure that you're staying with me. Do not be working ahead. So really, we're going question by question, so you really just need to be kind of like looking up here, because what's on my screen should be on your screen until I say, okay, go ahead and take a second to work.
Which test are we supposed to be on?
The 22.
Alright.
Is everybody on the screen that looks like this?
Yes.
Okay. Zach, where are you at?
Where are you supposed to test?
You have to, yes, again. Okay, good. All right. I'm gonna dim these. So we're just gonna kind of walk through these together. So a river river has cut a deep channel into the earth and exposed several layers of undisturbed sedimentary rock as shown in the cross section. Awesome. All right, so we're looking at this. Before I even look at my options, in my mind, I start thinking, okay, the law of superposition, things are in layers, the layers haven't been disturbed, right? So with all that in mind, where are you gonna find the oldest material? Sarah?
At the bottom.
Right, where's the youngest material gonna be?
At the top.
Okay, so with that in mind, I'm gonna look at this question. Which layer is the oldest? Okay, so I look at my options. Layer 1 because it's closest to the surface. Layer 2 because it has the greatest thickness. Does it have anything to do with thickness? No. Layer 3 because it has the most fossils. Does the number of fossils determine age? No. Layer 4 because it is on the bottom. Yeah, I like it too. Good. So we will go to the next arrow right here.
Next.
Okay. In 1968, the Deep Sea Drilling Project began extracting sediment cores from the ocean floor. Analysis of these cores has shown that the ocean basins are very young compared to the accepted age of the Earth. No rock older than 180 million years has been found. The core further indicated that the ocean sediments are absent in the mid-ocean ridges and get thicker moving away from the ridge. All right, so in my mind, I'm picturing, and the thing that's confusing about this question is they say sediment cores. So when you hear core, well, the Earth has a core, the inner core and the outer core. So I think that they actually throw that word core in there to be a little confusing, right? They will do that. That makes me mad, right? There's no reason they could have just said samples, right? No, they want to say sediment cores or sample cores, like, yeah, right? It makes you think of something that really has nothing to do with this problem, right? So the question says, this evidence helped to confirm what aspect of plate tectonics, right? So what I usually try to do is I think of anything that I already know. So if I'm at if I'm at the ocean, I know we talked about mid-ocean ridges, we talked about seafloor spreading, right? So those are some of the things that I automatically start to think of as I hear this question. So I'm gonna look at my options. So this evidence helped to confirm what aspect of plate tectonics. So you have younger rock here, and then it says the core further indicates that the ocean sediments are absent at the mid-ocean ridges and get thicker moving away from the ridge. So when I'm thinking about that, that's making me think of that seafloor spreading idea and what's happening at the mid-ocean ridge as the plates move apart and that new that new magma comes and fills it up. We said that that's why the ocean floor is so young, because it's continually being regenerated, right? So is seafloor spreading a good option? Yeah, I definitely wouldn't want to rule it out. Let's see if there's something better. Paleomagnetic reversals. Well, we did talk about paleomagnetic reversals. Magnetic reversals when the polarity of the Earth changed, but does that have anything really to do with this? No, so it is a topic that's related, but it's not really helping us with this. Existence of land bridges. Anybody like that?
No.
Location of the lithosphere. Again, lithosphere is important, it's one of our layers, but it's not anything specific to this problem necessarily, right? So Shelby says she likes A the best. Right, but just because that's a good choice, make sure you always keep reading, because sometimes there's two good choices and you have to pick the best one. Okay, so the following question has two parts. First answer part A, then answer part B. So part A, a student sets up an investigation to study how weathering occurs during freeze-thaw cycles. Rocks are weathered by water expanding when it freezes and cracks in the surface of a rock, which breaks apart. Okay, we kind of talked about this, right? Frost wedging, that idea. So the student collects rocks of the same size. So I see sandstone, granite, and marble. He places a rock into each of the 3 16-ounce containers and adds water. And freezes the container and thaws them. He repeats this 20 times and then observes the physical changes to the rocks. The materials for investigation are shown. it says select one question about weathering for the student to investigate. You have the option to choose any of these three, all right? You have to set up the materials to do any of those three. So what you have to do is pick one of those, and then based on what you selected here, it's going to, you have to match and set things up for part B. So how does temperature affect the degree of weathering? All right, so if we would choose that one, we go down here, click on the blank boxes in the table to select the variables to complete the setup to answer the question that you identified in part A. So remember when you ask a question and then you have to form your hypothesis around it and you have to set up the whole experiment to help you answer that question? If you choose a different question, like B or C, then you would have to make different choices in part B. Okay, so why don't you take a look at A, B, and C, decide for yourself which one of those questions you want to try to answer, and then set up part B that will answer that, and then we'll look at some of those answer choices or options.
Email Mrs. Miller and ask about your Chromebook. Okay. She's usually really good about getting back, so I'll check my email, and if I hear something before the end of class, I'll let you know.
Okay, so obviously on the testing day, take as much time as you want. I'm not gonna wait indefinitely for everyone to finish. What I'd like to do, did anybody choose A? Anybody choose question A to set up? Yeah? Okay, so for A, how does temperature affect the degree of weathering? So if you picked A, on part B, how are you gonna set it up? Notice how it says there may be more than one correct answer too. So, how did you set this up, Shelby?
I put granite
Okay,
and then marble.
Yep.
And then sandstone.
good, you're trying all three samples, good.
And then I put 16 ounces for all of them.
Good, because we need to keep that variable the same, because that's not what you're testing, is the amount of water. You're testing how does temperature affect, and then what did you do here?
0 for all of them.
Okay? Now, the only thing that I don't like about this is if you are testing temperature, shouldn't that be the variable that you change? Because you you're testing that out on each one of these, here you're actually changing the sample, so if you would have made these granite, if you made, all of those granite, you kept water the same, changing the temperature is the variable that you would have to change. Oops. So whatever you say you are changing, that needs to be, or excuse me, whatever you say that you're testing, that's the variable that you need to be changing. Okay? Does that make sense? So you would have gotten partial credit for that because you had the first one set up good. All right? Because here you're changing temperature and you're going to see the effects of that on the granite. So if you had all three samples, you wouldn't know it's the sample that was affecting it or the temperature that was affecting it. So even though you have three rock types available, you could only choose one of them. So you could have picked sandstone for all of them, and that would have given you complete points. Or you could have clicked on all of marble. So that's one thing that's nice, is that there are multiple answers that are correct. But if you picked A, you had to have the same rock type, the same water amount. So again, these could have all been 4, or they could have all been 10. But what was different was the number, the temperature. So did anybody do B? How do the freeze-thaw cycles affect different rock types? All right, so tell me how to set that one up, Nye.
I did granite, marble, and sandstone.
Okay, that's changing the 3 rock types. Okay, what else?
I did all of them 16.
Okay.
And all of them -20.
Okay, very nice. You have to, if you're testing the rock type, that's the variable that you change, right? Water amount and temperatures have to stay constant. Okay, same thing, you could have picked 10 or 4 as long as it was 4, 4, 4, 10, 10, 10. Okay, so the only variable that you're allowed to change is the one that is being changed, like that you're testing in the question. So C, how does the amount of water present affect the freeze-thaw cycle? So did anybody do C? Go ahead.
For the type of rock, I did all of them granite.
Okay. And again, they could have all been marble or all been sandstone.
And then for the volume of water, I did 16, 10, and 4.
Okay. One of each.
And then I did -10 for all the temperatures.
Okay. As long as all the temperatures were the same, it doesn't matter what they were. Very good. So there's a lot of right answers. Basically, you're just setting it up based on which question you decided to pursue. So spider plants can reproduce by spawning plantlets on long, thin stems. The plantlets can be removed from the parent plant and placed in soil. When planted like this, the plantlet becomes a new spider plant. So it's kind of like taking a cutting, basically. Okay? Click on the blank box and select the word or phrase to complete the sentence that describes the inherited traits of the new plants grown from the plantlets. So these plantlets are going to be, they're going to have none of the inherited traits, less than half, more than half, or all. What do you think, Sarah? Okay, so in my mind, when I look at that, I think, okay, it's basically a clone. It's going to be an exact copy because it says you have the one parent plant, one parent. So there's only one parent. We know they're reproducing using meiosis, and meiosis is telling us that it's going to have identical genetic information. Okay. All right, number 5. A student sprinkles iron filings on a clear sheet of plastic. The student then places the sheet of plastic on top of a bar magnet and taps the edge. The iron filings take the following shape. Okay. Wants to know where the magnetic force on the iron filings is the strongest and how do we know? All right, what do you think?
Your phone is pointing down.
What's that?
Your phone is pointing down.
Oh, geez. Thank you. Okay, thank you. Alright, so as I look at this, iron filings are attracted to the bar magnet, so as I look, I see a concentration in two places. Where do you see the filings most attracted to? What do you see, Fletcher? Okay, so at the edges, which we call the poles, right? So let's look through our answer choices. So it says region A because it's closest to the magnetic pole. Well, that's not a bad answer choice, right? Let's keep that as a possibility. B, because region B, because it's the direct center of the magnet. Well, do you see a lot of attraction of the filings here? Not really. I mean, it is the center of the magnet, but that doesn't mean anything. Region C, because the iron filings form a curved line there. Does the curve of the line mean anything? Not really. And region D, because it is the greatest distance from the pole. We still like A? Okay, good. So, again, even though A is the correct answer, make sure you read all the other possible choices just to make sure that there isn't something better. All right. Diagram shows a river that is carrying sediment into the ocean. So I always want to orient myself and make sure that I'm really paying attention to what I see. So here's a river and it's flowing into the ocean. I can almost see the river water like right here as it's kind of matching that coloration. And here obviously is the ocean. So I want to make sure I see what the picture's showing me first. And then location T is right here. What will happen to most of the sediment being transported by the river water when it first enters the ocean at location T? All right, so it says most of the sediment will erode the beaches. Well, that's a little tricky because beaches do get eroded. And so that's one way that they're trying to trick you. You're like, oh yeah, beaches erode. So you might get some people to bite on that and be like, okay, yeah, beaches will erode. But it's not going to erode because the sediment is eroding it, right? It's going to erode because of the action of the waves and maybe weathering and things like that. Most of the sediment will dissolve in the water. Well, sometimes sediment will dissolve, but usually not dirt. Dirt's not going to dissolve, right? Right? Most of the sediment will be evenly distributed throughout the ocean. I mean, evenly spread out? I don't know. I mean, you'd think it'd be like where it's most concentrated, where it's coming out, right? Logically, it's not going to just perfectly spread out, is it? D, most of the sediment will collect near the mouth of the river near the shore. What do you think? Out of all those four, what do you think sounds like the best option, Sarah? Yeah. What do we know forms usually as fast-moving river water dumps into that, and that water slows very rapidly and causes that sediment to dump?
A delta.
A delta. Good. And so it's that deposition process, right? The fast-moving water can hold the sediment. As soon as that water slows as it enters into that big ocean, then it doesn't have the same speed and it drops the sediment. Good. Forming that delta. So D is the best answer. All right, the following question has two parts. First answer part A and then answer part B. Students conduct an investigation to show how density varies within depth of the surface at the center of the earth. They use different types of sediment. The table shows the density measured in grams per centimeter cubed or G/cm cubed. For each type of sediment, the student uses, the table shows the density of measured in grams per centimeter cubed for each type of sediment used in the investigation. So we don't know what these sediment samples are, but they gave them names of L, M, O, and P, and it also has the density. So this is what's a little frustrating because it clearly says in my standards, do not assess like actual densities. So like we never measure densities by number. We like ranked them like, oh, this is the most dense, this is the least dense based on their arrangement in a container possibly. And then here they're giving you actual numbers. So with density, and we'll actually do this a lot next year, we calculate density. But density, the bigger the number, the more dense the material is. All right, so the higher the density number, the more dense it is. So as I look at this, which one of these things is going to be the most dense? What do you think, Brady? Okay, M is 2.3. Which one is going to be the least dense? What do you think, Jackson?
L.
Good, so M is gonna be at the bottom, it's the most dense, L is gonna be at the top. So kind of just get that oriented in your mind, that's what those numbers represent. The bigger the number, the more dense, so it'll be at the bottom. So the students add 50 grams of each sediment sample to a jar of 0.5 liters of water. They put the lid on tightly and shake the jar carefully for 1 minute. They set the jar down and observe what happens over the next few minutes. Basically like what I did with my little bottle. Do I still have it up there? Yeah, my little sediment bottle, right? So select the boxes in the table for each sediment sample. Layer 1 represents the center of the earth. So where is the most dense material of the earth found? Is it going to be at the crust at the top, or is it the core at the center? Where's the most dense material found? What do you think, Claire? Going to be at the core. All right, so at the center of the earth, and layer 1 is meant to represent the core. So you have to put together the idea that you're looking for the most dense to represent the layer that should be all the way at the center. So back to, I can get all this to fit, there we go. Brady told us that M was the most dense, so that would have to be layer 1. Then we're working our way to the next dense. Shelby likes P. And then we had 2.3, and on the paper, if I was you, if I had paper in front of me, I would put these in order. I'd go 2.3, 1.9, 1.6, 1.1, and I would actually write them so I didn't get them confused. M, P, O, L. If I was doing this, that's what I would do, just to make sure I didn't get something confused. So if I'm going to the third in line, 1.6 is going to be O, right? And then my very top layer is going to be L, right? Most dense, next, next, next. Okay. All right. Going to part B. Which process are the students able to model and observe in the investigation after carefully shaking and setting the jar down? Right, so are we seeing how the plates move? No. Are we looking at seismic activity or anything with earthquake energy? No. Are we looking at radioactive decay? No. All of these things are things that are definitely related to the layers of the earth. How we have the internal heat, how we have the energy that's released as plates form that, as they strike together at those plate boundaries. But that has nothing to do with this. So by order of elimination, even if you're like, I can't remember what planetary differentiation is, these three are not good choices, right? And remember when we talked about, that's why we ended up with the layers, because as the earth was all hot, the most dense came to the center, and then it kind of layered out just like my bottle did. As it cooled, then it kind of locked those densities in place, right? And if you think of our song, as you go down, temperature increases, as you go down, density and pressure increase, right? But the name of that is the planetary differentiation. Okay, this is where I would most definitely want to be using my scrap paper if I was you. All right, so it says in pigeons, gray feathers are dominant. So what I would want to do on my paper is I would want to put, I would put gray, because I would want to keep that in my mind. And then R is going to be red. See what they did? This is kind of tricky. Most of the time, we assign the dominant color the letter. Like, you would think this would be a capital G, and they tricked you, or they're trying to be tricky and make it R. So you think that the capital R means red. Why would they do that? Like, that is just dirty. I don't like those tricks and those little games that they play. That's frustrating to me, because almost always, you are, in all examples and all kinds of things, we're given the letters to represent, like you choose, if it's a good letter to use, like use a capital G, it's very different from a lowercase g, but they use the letters R. So I would always wanna write this out so I can keep referring back to that as I go to answer this question. The diagram shows some of the inheritance patterns of feather color in pigeons over 3 generations. Move the genotype labels into the blank boxes for the F1 generation so that the F2 generation is produced. Okay, so for this F2 generation, we need to have the possibility of having all 3 of these genotypes. So what is our only combination pair that makes it possible to do this? And so really all you have to do is take a second and try to do this. You only have 3 options, right? You have big R, you have homozygous dominant versus homozygous dominant, or you could do homozygous recessive versus homozygous recessive, or you could do homozygous dominant versus homozygous recessive, or you could do all heterozygous. You have lots of, right? So thinking of the Punnett squares you've done, you probably don't have to try all of those, but if you narrow it down to a couple possibilities, set up the Punnett squares, and then you better get offspring that give you those possibilities. So any guesses or any ones that you want to kind of try out as a Punnett square to test? What do you think, Jackson? Okay. For one of them, and what about for the other parent? Oops.
The same thing.
Okay. So do a cross of big R, little r, big R, little r. So we get homozygous dominant, heterozygous, heterozygous, and we do get a homozygous recessive. Now, if you look out and you pick those parents first time out, awesome. If you would have picked any different combination, you won't get all 3 offspring possibilities. And so you'd have to eliminate that as a parent choice. So you probably have done enough of these at this point where you can at least realize that you're gonna have to get the little r's, you're gonna have to have little r's in the parents, right? So there's some strategy to it, but if you set up lots of different Punnett square options, it'll get you to the right answer, even if you don't feel confident about kind of eliminating things, a whole lot on your own. So if we drag these, that becomes our final answer. If you want, you can change your mind. You're like, no, I don't like that. Let me try this. And you're like, oh, no, I don't like that. Let me go back. You'd be like, yep, this looks great from the get-go. So you can just drag and drop them. Okay? But if you set up the Punnett square and you don't get all 3 offspring possibilities, then that is not a good setup. This just happened to be where you do get the possibility of all 3, so that is the correct answer. Okay, let's go ahead and stop there. Tomorrow, I will have directions in Google Classroom.